A mysterious visitor is speeding through our solar system, a strange object unlike anything we've ever seen. This is 3I Atlas, the third confirmed interstellar comet, and it's shaking up everything we thought we knew about these cosmic wanderers. Discovered only months ago, already nearly 100 scientific papers have been written about it. But today, we'll cut through the jargon and confusion. Here's the real story behind 3I Atlas and why it's so extraordinary. 3I Atlas is currently making its closest pass to the Sun, a point called perihelion. On October 29th, it was about 1.4 astronomical units from the Sun. That's just inside Mars's orbit. While not close enough to scorch it, the Sun's heat triggers powerful changes. The comet's surface material vaporizes, releasing gas and dust in a process known as sublimation, creating the glowing coma and the iconic tail pushed away by solar winds. Sadly, we missed seeing this cosmic dance directly, because from Earth, the comet was hidden in the Sun's blinding glare during perihelion. But where did 3I Atlas come from? It was first spotted on July 1, 2025 by the global telescope network called ATLAS. At first, it looked like any other asteroid, but astronomers soon realized it was moving too fast to be bound by the Sun's gravity. At 58 kilometers per second, the comet was moving faster than any other object ever recorded in our solar system, even when it was as far out as Jupiter's orbit. Its hyperbolic trajectory means it's here just for a quick visit from interstellar space, passing through our neighborhood before returning to the vast reaches between stars. Compared to its predecessors Oumuamua and Borisov, 3I Atlas is massive. It could be up to 5.6 kilometers across, making it the largest interstellar object we found. It also moves twice as fast, and here's the strangest part. It's entering almost perfectly aligned with the flat plane where all the planets orbit, a surprising cosmic coincidence. Tracing back its path over 10 million years, astronomers believe 3I Atlas came from the thick disk of our Milky Way galaxy's core region, a quiet, ancient area where objects can drift undisturbed for billions of years. This makes 3I Atlas possibly as old as 7.6 billion years, nearly twice the age of Earth itself. Let's dive deeper into what makes 3I Atlas so peculiar. When it first formed a coma, it was mostly carbon dioxide gas, not water vapor like most comets. This early carbon dioxide sublimation happening far beyond Jupiter's orbit was unexpected, because CO2 needs far less heat to vaporize compared to water ice. Oddly, the comet's initial tail pointed toward the Sun, not away as expected from solar wind. Scientists think the early CO2 cloud was too dense for the solar wind to push back initially, creating the strange sun-facing tail. Another surprise came from metals. The comet's coma contained nickel, but almost no iron. A puzzling discovery, since these metals usually travel together, formed in supernova and spread across space. Only as 3I Atlas got closer to the Sun did iron start appearing, normalizing the metal ratios in its glowing envelope. On October 3, 2025, 3I Atlas made its closest approach to Mars, just 0.19 AU away. Cameras on the Perseverance rover and orbiters captured images. Though faint, these are some of the clearest views we have of this cosmic interloper. What lies ahead? On March 16, 2026, 3I Atlas will pass by Jupiter at 0.36 AU. Juno, the lone spacecraft orbiting Jupiter, might be able to snap the final images before the comet slips forever back into interstellar space. Cooler and less active, but forever changed by its journey near the Sun. Why does 3I Atlas matter so much? Because it challenges everything we thought we knew about comets and the formation of planetary systems. Its unique composition, trajectory, and size hint at a vastly diverse universe, where what's normal for one star system can be utterly alien to another. As we unravel the mysteries of 3I Atlas, we gain new clues about how our galaxy evolved, and perhaps about the origins of our own solar system. As 3I Atlas moves farther away from the Sun, it will cool down and its activity will decrease. But the journey it has taken already offers invaluable insights. Each observation helps astronomers piece together the story of how interstellar objects traveled through our galaxy and what kinds of materials they carry with them. Understanding 3I Atlas helps answer big questions about the building blocks of planets and the origins of water and organic molecules, which are essential ingredients for life as we know it. One of the most exciting aspects of studying 3I Atlas is what it can teach us about other star systems. Unlike typical comets from our solar system, this visitor's makeup suggests a very different chemical environment. And that means the processes that formed it may be vastly different from those here. Scientists are already planning future missions that might be able to intercept interstellar objects like 3I Atlas to bring back samples or take detailed measurements up close. Imagine what secrets could be unlocked with just a little more time and technology. For now, 3I Atlas reminds us how dynamic and interconnected our galaxy is. A tiny traveler from a distant star system, journeying billions of kilometers to pass through our cosmic neighborhood. The universe is full of wonders, and 3I Atlas is a shining example. Thanks for joining this exploration into one of the most bizarre and fascinating visitors ever seen. Make sure you don't miss future updates, because space is always full of surprises. Since its closest approach to the Sun, known as perihelion, 3I Atlas has shown unexpected behavior that has deepened the mystery surrounding this cosmic visitor. Recent observations, including images taken after perihelion, reveal that 3I Atlas currently shows no visible cometary tail, a stark contrast to what scientists anticipated from such a comet heated by the sun. This tailless appearance has stunned researchers because typical comets produce a glowing tail of gas and dust pushed away by solar radiation. But 3I Atlas remains a compact point of light, hinting that it might not be a normal comet at all. Further intrigue comes from the non-gravitational acceleration measured in 3I Atlas's trajectory, suggesting it is losing mass at an extraordinary rate. This loss likely comes from the comet expelling dust and gas plumes unevenly, effectively giving it a boost akin to a kick from a natural thruster. Harvard astrophysicist Avi Loeb has proposed that the comet could lose up to a tenth of its mass in just 1 month due to this activity. The composition of 3I Atlas is also confounding. Early in its journey, the comet's coma was rich in carbon dioxide gas rather than water vapor, which is unusual and points to a formation in an extremely cold environment far from its original star system. Metals detected in the coma showed atypical ratios, with initially nickel present but little iron, which only normalized later as the comet approached the sun. This unique chemical signature suggests formation processes very different from those in our solar system. Imaging efforts continue as 3I Atlas moves outward. On November 5, 2025, images captured shortly after its conjunction with the sun confirmed its cometary nature with a diffuse coma pattern. Upcoming observations by the Hubble Space Telescope and the James Webb Space Telescope are planned to further analyze its gas composition, including sulfur to oxygen ratios, and track its fading activity as it recedes. The comet's path will bring it near Jupiter on March 16, 2026, when the Juno spacecraft may have a chance to capture its final images before 3I Atlas exits our solar system forever. The data collected could provide crucial insights into how interstellar objects are formed and how they evolve during long journeys across the galaxy. 3I Atlas challenges many assumptions about comets and the diversity of material in our galaxy, hinting at vastly different planetary system formations and chemical environments than those we know. Future missions aiming to intercept interstellar objects could finally unlock deeper secrets about the origins of water, organic molecules, and potentially even life beyond our solar neighborhood. Stay tuned as 3I Atlas continues to illuminate the complexities of cosmic wanderers and expands our understanding of the universe's vast, dynamic interconnectedness.